Chapter E in basic calculus is going to be the addition and subtraction rules. So we'll say here the addition and subtraction rules. And we're doing derivatives. So let's remind ourselves what the general formula is for a derivative. F of x is equal to the f dx, like this. And that's going to be the limit as delta x goes to 0 of delta f over delta x. We can write out as the limit as delta x goes to 0 of f of x plus delta x minus f of x divided by delta x. Now we're interested in a function f of x that consists of a sum of two other functions, which I'll call u and v. So as we apply the definition, we're going to have the derivative of f of x is going to be equal to, putting them both in together, let's go ahead and take a second to write down what the f of x plus delta x would be, since we'll be needing that. Well, that would be u x plus delta x, and we would add to that v x plus delta x. So now we're ready to use the formula. So the derivative would be the limit as delta x goes to 0, and now we would have lots of stuff in the numerator. We would have all of this first, so we'll have u x plus delta x plus v x plus delta x, all of this, and then we need to subtract the f of x, which is u of x and the v of x, and all that's divided by delta x. Now I'm going to rearrange things in the numerator. The limit as delta x goes to 0. I have lots of stuff. I'm going to group all the u's together. So I have u of x plus delta x minus u of x. I got that one. And then I'm going to add that to the grouping with the v. So that would be v x plus delta x minus v of x divided by delta x. Then the next step, and probably by now you may be wondering why am I doing all these steps. You see where we're heading with this. We're going to split these up. So we're going to have here u of x plus delta x minus u of x over delta x. And then we're going to have the second one here. The limit as delta x goes to 0 of v x plus delta x minus v of x over delta x. And at one point I'll list for you limit rules, which we don't prove in this class, but the limit of a sum is equal to the limit of each component. So using that, you see this is going to be the derivative with respect to x of u, and this is going to be the derivative of v with respect to x, and we have our result. In other words, df dx is equal to du dx plus dv dx when our function f is a sum. We simply take the derivative of each one and add them together. Now, you could see that if we had started out with the minus sign here, everything would still work. So we could say here that this works for the case, I'll call it, say, g, u minus v, then dg dx would be du dx minus dv dx. So it works for addition and subtraction in a similar way. How about if we use this right now to find the derivative of our general quadratic equation? We actually know the derivatives of the component parts. We have done that already in our class. So we know that for x squared you get 2x. So this would be 2ax. When you have bx, you just pull the b off. Remember, mx, y equals mx plus b type thing. So that's plus b, and the derivative of a constant is 0. So we have a result here for the general quadratic equation. And since we know that the derivative of x to the n is n, x to the n minus 1 power, we can do all kinds of things. We could do, for example, where x is cubed, a general cubic or quartic, we could do all kinds of stuff. So here, if you had y is ax cubed plus bx squared plus cx plus d, if you had something like that, for the y prime, you would get 3ax squared plus 2bx plus c plus 0. So this is very, very powerful rule that we use in calculus all the time. The derivative of a sum or difference of functions is done very easily by taking the derivatives of the individual components, either adding or subtracting them.